This is Dr. Sridhar back to you with another video session on classification of control systems. Now, what are the parameters we are going to select and what are the parameters on which we are going to divide and classify these control systems? So basically, widely we are speaking, there are variety of classification you can see in the control systems, and those classifications are possible based on the parameters and what is the purpose and what is the application. Based on all these parameters, we can classify the control systems into different types. So the majorly some important classifications are linear and non-linear systems, static and dynamic systems, time variant and time invariant systems, causal and non-causal systems, and in addition to this, one important classification also we observe, that open loop control system and closed loop control systems. Already in the previous videos, we have discussed about the open loop control systems and closed loop control systems, because that classification also we can do with the help of feedback. If the feedback is not there in the control system, that could be say as open loop control system. If the feedback is connected, then that will be a closed loop control system. So based on the feedback connection, if it is existing and if it is not existing, so that is the one more classification. Of course, out of these four, that is very, very important. So along with the open loop control systems and closed loop control system, with that classification, and few more classifications are linear, non-linear, time variant and time invariant, causal and non-causal systems, static and dynamic systems. So these are the major classifications of the control systems. And what is the linear system and what is a non-linear system? Linear system means in its name only, the system. Now I am talking about the systems, now not about the input and output, but with the help of input and output, we are going to decide whether the system is linear or not. Okay. Now in this linear system, input and output, it will be measured based on the information that input and output is going to present to us. Now we are going to decide what type of system is that. Now in the linear system, the input and outputs are proportional to each other. Now for example, if you are taking the resistor, now resistor is nothing but I is equal to V by R or V is equal to I into R. Now if you are establishing the relation between the input parameter and output parameter, so what is the input and what is the output? Suppose if the input is, now vice versa you can take here, no matter, because through the resistor, suppose if you are taking the resistor, now through this resistor, if the input current if you are applying, so therefore definitely there will be a drop across the resistor V, and this is the R. So what is this R here? This is nothing but the system. This is the plant. Now this plant is having one resistor. Now for this particular plant, if the current, whatever it may be, either voltage or current, whatever it may be, but I am taking this input parameter as the current. If the current is allowed to pass through the resistor, means if this I as an input, if you are allowed to pass through a system having a resistance R, then the output will be a voltage that is nothing but the drop across the resistive system. So here what is the input and what is the output? Current is the input and output is nothing but the voltage, if this is in this example. So if you are establishing the relation between input and output, the relation is nothing but it is linear. So that's what linear system is. So what is the thumb rule here? So always linear systems obeys homogeneity principle and superposition principle. So these two things are very, very important. Technically, if any system is obeys these two principles, then the system could be said as a linear system. And the linear system is nothing but always the relation between input and output is a linear in the nature. The best example for this is a resistor. So similarly, if you are taking the non-linear system, now the best example is nothing but it is a diode. Now if you could see the characteristics of the diode, if you are allowing some voltage as the input or current as the input, now not the current, let me take the voltage as the input for the diode. So if this is the diode, now for this, if you are applying a voltage between the anode and cathode, now up to some extent, now there will be a current, it will be passed. So what about the variations of this particular current? The variations of the current is clearly indicated in the graph. So this is not linear between the input and output. So that is the case. This is the example for the non-linear systems. And what about the relation between the voltage and current? The relation is nothing but I is equals I naught into exponential times of V2 time tau minus 1. Here the relation between the current and voltage is not linear. So this is the example for the non-linear systems. Output of the system does not vary linearly with the inputs, and it will not obey any superposition principle or homogeneity principle. So these are the definition comparison between the linear and the non-linear system. This is the one of the important classification of control systems. So second, if you could see static system and dynamic system. What is the static system? Static system in another form, this is also called as a memory-less system. Now it will not have the information of the system, or in the system, the system is nothing but it is the combination of various components in it. Now any component, if does not have any previous information with it, now this is the example for the static system. So the best suitable example is nothing but if you take resistor, now R, capital R, or resistive. In the resistive systems, it will not have any initial information, initial conditions with it. So that is the best example for the static element or static system. So coming to the dynamic system, in the dynamic systems what happens? Now the example is nothing but either inductor or capacitor. If any circuit or if any system is the combination of inductors and the capacitor, now inductor, if you could see, now it will have some initial information with it. What is the initial information? Now it will have some initial current. So now if you are taking the capacitor will have initial voltage. So these L and C, these are the examples for the dynamic systems. Now whenever you are computing the mathematical, if you want to analyze the inductor behavior, definitely you have to consider the initial information that inductor and capacitor is having. So these are nothing but dynamic systems are nothing but the memory full. Definitely there will be some information that inductor and the capacitor will have. So these are the examples for the dynamic systems. So this is the one type of classification the control system is having. So next, time variant and time invariant. Now in its name only, time invariant. So the system will not vary with respect to the time variations. Now in time variant system, as long as time varies, automatically if the system performance also varies, or the system behavior varies, or the system acting differently, then that would be a time variant systems. Now ideal resistor, if that is the type of the system, or in the system if only resistor is connected, and if you are saying that resistor is ideal in the nature, it will not change even if you are going to start the resistor, or if you are going to bring that resistor at t is equal 0 or t is equal 10 or t is equal 100, whatever it may be. So it means it will not vary and the response won't be changed at what instant that was brought into operation. So that is nothing but irrespective of time, it will behave. So only what is its performance, that will be same for any time values. So this is a time invariant system. And time variant system. Time variant system means, now if you are taking in this presentation, I am presenting an aircraft here. In this aircraft, once if it is going to start, it will have full of fuel inside. So it will have its own mass. Let us say 1 ton, let us assume. And after that, once it starts flying, after 15 minutes or after half an hour, what happens? Its weight is going to decrease. Why? Because fuel, it will be burned proportionally. Now once the fuel burns, then automatically the weight of the aircraft is going to reduce. So at what instant, means at what time that vehicle is going to start, and from the starting onwards, after 5 minutes or after 10 minutes, the weight of the vehicle is going to change. Here what is the plant here? Plant is nothing but it is a control system, or that is nothing but a plant is nothing but it is a aircraft. It is along with the fuel tank. Now fuel tank weight is going to decrease as time progresses. So it means this is the best example I feel for time variant systems. This is also one of the important classification the control system is having. And this is the causal and non-causal systems, and weather forecasting and missile guidances are the example for the non-causal, and motor or generator and thermostat based AC is nothing but the example for the causal systems. Now here causal system is not anticipatory. No, it is not going to anticipate, but in the non-causal system is going to anticipate. Suppose weather forecasting related issues. This is the one a small classification in the control systems. And in addition to this major classification, we have a few more classification based on the parameters. So in the first case, if you could see based on the hierarchy, so that is nothing but open loop control systems and the closed loop control systems. In addition to them, optimal control systems are there, adaptive control systems, and learning control systems. These are the based on the hierarchy. Now how the control system is going to classify. So next classification is based on the presence of human being. Now if the human beings are involved, then that is nothing but the manually operated control systems or manual control systems. If the human beings are completely absent, then those are called as automatic control systems. And next classification is depending on the presence of feedback. Now if the feedback is present, then that becomes closed loop. If the feedback is not present, then that is nothing but the open loop control systems. Of course, about this we have discussed so much in this video. And one more classification is the purpose and application of the system. So where you are going to use this control system and what is the major purpose of this chosen this control system. So based on this few classification, few examples I am presenting here. Now these types are not restricted here. This may be elaborated based on the application, based on the area, in which area and for what sake, for what application you are bringing this control system concepts. So that also matters here. But for better understanding, I am presenting few cases. So first one is position control system and process control systems, traffic control systems, velocity and temperature control systems. Now everybody knows about what position, what process, what traffic, what velocity and what temperature is. Anyhow, in the previous videos also we have discussed about temperature control systems, velocity control systems, and here sometimes this traffic control systems is very, very important in some of the cases, especially in our Indian scenario. As per my context, traffic control systems are open loop control systems because the traffic lights are going to regulate irrespective of the traffic in that particular region. So these traffic control systems are the best example for the open loop control systems. Don't confuse with this. Of course, traffics are going to stop us, but it is not going to stop the people or the vehicles based on the traffic or density of the traffic in that particular direction. So that's why traffic control systems are the example for the open loop control systems only. Now classification of feedback control system, in addition to the previous classification, we have few more that is based on the analysis and design. So we are going to divide the control systems as a linear and non-linear. We have discussed about what linear and what non-linear. As long as any control system or any system is obeying homogeneity and superposition principle, then that could be said as a linear control system. Otherwise, those are the non-linear control systems. Depending on the parameters. Now, already we have discussed about this time invariant and time variant. Depending on the types of signals, continuous data and discrete data control systems. Now, AC and DC control systems also. Of course, this is very simple. AC and is nothing but it is a modulated and unmodulated DC. These are the different types of control systems we can come across with this. And depending on the number of inputs. Now, if the inputs are more than one, then those are nothing but the multi-inputs and multi-outputs. So, MIMO system, MIMO. Or if the input is one and output is also one, that is nothing but the single input, single output. Sometimes single input, multiple outputs. Sometimes multiple input, single input, single output is also possible. So, those two are also in addition to this CISO and MIMO, we can divide the systems based on the inputs and outputs. And one more classification is upon the type of or type number. What is the type means? Type is nothing but it is a number of open loop poles at the origin. Of course, we are going to discuss this type of classifications of the control systems in the future videos. So based on the open loop poles at the origin, how many number of open loop poles that origin is having? So based on this, the systems, the control systems can be classified as type 0, type 1, type 2, type 3, etc., etc. Now, in addition to that, one more important classification is based on the order of the system. What is the order? Order is nothing but that is the maximum power of the characteristic equation in the transfer function. So here at this moment, this classification is, of course, it is tough to understand. So let me explain about this based on the number of open loop poles at the origin and order of the origin, and one more classification is damping in the future videos. Till that, please excuse me, because anyhow, as a part of this classification of the control system, we had to give this classification also. That is the reason which made me to explain about these types of control system as part of here. Now, depending on the order of the system may be first order, second order, third order, etc., etc. But at UG level, at BTech level, second order control systems are more than sufficient, which I feel. Otherwise, third order system could be discussed. Now, last classification is depending on the type of the damping. Now, damping is nothing but, so this is a very, very interesting and important concept. Damping is nothing but every system. If the system is existing, means the system will have some sort of opposition to the external changes. So that made me to classify the control systems into different classification. One is the undamped system. Undamped means now if the system is going to opposite any external variations or external changes, now the system is nothing but undamped system. Underdamped systems means now it has some sort of opposition, relatively lower value of opposition. Those are the underdamped systems. And one more is nothing but the critically damped systems. So some critical values, opposition will be there by the system to the external inputs, but at some finite value, which is nothing but the 1. And last one is the overdamped. Overdamped systems are nothing but if the opposition is more than 100%, then that is nothing but the overdamped type of control systems. So in this video today, I have presented different types of control systems with definitions and with examples. I hope you might have enjoyed this video session. Thank you very much. Thank you for watching this video.
Like, share and subscribe. Hit the bell icon for more updates.